I want to tell you about the solar system, but not in the familiar way, not as a list of planets, and not through the colorful illustrations you have seen for years. What matters lies elsewhere. It lies in the true scale of the place you live in, and this is something most people never realize. The solar system diagrams found in textbooks and on the internet are all wrong, not because someone is trying to deceive you, but because there is no other choice. The real distances between celestial bodies are far too vast. If drawn to scale, you could not fit them on a page, could not hang them on a wall, and could not even spread them across an entire stadium. Those familiar images are forced to sacrifice truth in exchange for the ability to illustrate. When you look at those diagrams, you see 8 planets neatly arranged, evenly spaced, with an asteroid belt sitting between Mars and Jupiter, all orbiting a central star that appears only slightly larger than Jupiter. They help you remember names, but in terms of scale, they are completely wrong. If those images reflected reality, the solar system would be a chaotic place. The planets would constantly tug violently on one another through gravity. Orbits would be distorted. Collisions would occur frequently. The night sky as seen from Earth would not be filled with calm points of light, but with enormous disks hanging close together, overlapping and blocking one another. But that is not what you observe. When you lift your eyes to the night sky, the planets appear only as points of light. Even Venus, the brightest and closest planet to you, is nothing more than a tiny dot. There are no large disks. There is no sense of proximity. There is a very clear reason for this. The distances between worlds in the solar system are so vast that they far exceed human intuition. To grasp this, I need to take you away from abstract numbers and place you inside a more familiar image. Imagine the central star of the solar system shrunk down to the size of a basketball and placed in the middle of a room. Where, then, should Earth be? The natural instinct of most people is to place Earth somewhere in the same room, a few meters away. But that estimate is completely wrong. At this scale, Earth would be a tiny bead, about 2 millimeters in diameter, and you would need to place that bead about 26 meters away from the basketball. That distance is roughly equivalent to 2 school buses parked end to end, and that is only the 3rd planet, Neptune. The farthest of the 8 planets would be located nearly 1 kilometer away, more than half a mile. To represent this scale accurately, you would need a large stadium, and most of the space inside it would contain nothing but air. Before expanding further outward, I want you to return to what is most familiar. Earth, the planet you are standing on, has a diameter of about 12,700 kilometers. That number sounds enormous. If you were to walk around the equator, traveling 8 hours a day at a steady pace, it would take you more than a year. If you drove continuously at high speed, the journey would still take nearly 2 weeks. From the perspective of the surface, Earth is a vast world. Oceans stretch to the horizon. Mountain ranges take days to cross. Continents are separated by thousands of kilometers of water. You could spend an entire lifetime traveling and still not see it all. But within the solar system, Earth is a small object. The closest object to Earth, aside from artificial satellites, is the Moon. It orbits Earth at an average distance of nearly 400,000 kilometers. This distance is so familiar that it is easy to overlook, until you place it in a physical context. Light travels at about 300,000 kilometers per second. That means light from the Moon takes more than 1 second to reach your eyes. When you look at the Moon, you are seeing it in the past, even if that past is very brief. Astronauts who traveled to the Moon took about 3 days to complete the journey. The fastest probes ever built could reduce that time to just a few hours. But the remarkable point lies elsewhere. If you lined up all 7 of the other planets of the solar system side by side and placed them into the space between Earth and the Moon, they would fit. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune together would occupy a length of nearly 400,000 kilometers, almost exactly the distance to the Moon. The gap between Earth and its only natural satellite is wide enough to contain all the other worlds, right here. In the smallest corner of the cosmic neighborhood you inhabit, empty space already dominates absolutely, and to fully understand that, you need to look at the center of all motion in the solar system. The star around which the planets orbit has a diameter of nearly 1,400,000 kilometers, more than 100 times wider than Earth. If Earth were the size of a grape, That star would be a sphere nearly 2.5 meters tall, but its outward size still does not tell the whole story. Inside that sphere, about 1,300,000 Earths could fit. And even after packing in that many, there would still be empty space left. This central star contains nearly all the mass of the solar system, all the planets, moons, asteroids, comets, and cosmic dust combined make up only a tiny fraction. Every second, it converts millions of tons of matter into energy. A minuscule portion of that energy reaches Earth, yet that alone is enough to warm the surface, drive weather, and sustain life. When you place all of these facts side by side, the initial illusion begins to collapse. The solar system is not a tight system of closely packed worlds. It is a structure of astonishing emptiness. The planets do not dominate space. Empty space does. From here, every familiar perception of your position begins to shift. And as you continue deeper, that shift will become even more profound. I'm telling you a truth that is not intuitive, yet it is foundational to the entire solar system. Most of what exists around you is not planets, not comets, and not rock or gas. Most of it is empty space, void, nothingness stretching in every direction. When the solar system is mentioned, the human mind automatically searches for objects. It looks for planets, for orbits, for something that can be named. But if you were to stand at any random position within Neptune's orbital range, the probability of you being near an object would be extremely low. The most likely outcome is that you would be in the middle of a region where there is nothing of significance. The solar system is not a dense collection. It resembles a structure so diffuse that it is almost empty. The planets occupy only a very small fraction of the total volume. They are like grains of dust scattered through a space far too vast for human intuition to naturally grasp. This emptiness is not accidental. It is a direct consequence of how gravity operates. When a planetary system forms, matter does not distribute evenly. Most of the mass concentrates at the center. The remaining material is pushed outward and arranged into stable orbits, leaving enormous gaps in between. The distances between planets are not a design flaw. They are a necessary condition for the system to survive over long timescales. If the planets were closer together, gravitational forces would constantly disturb their orbits. The system would become chaotic and unstable. It is the empty space that preserves order. From Earth, the night sky appears crowded. Thousands of stars are visible at once. But this is a visual illusion. Those points of light lie at vastly different distances. Between them are regions of space that contain nothing more than a few scattered atoms, even within Earth's own orbital neighborhood, which humans often imagine as a busy central zone. Space still dominates. The distances between Earth and Venus, and between Earth and Mars, are so large that light takes several minutes to cross them. There is nothing in between but silence. Even the asteroid belt, often imagined as a dense wall of rock, is itself a nearly empty region. The asteroids within it are separated by hundreds of thousands, sometimes millions of kilometers. If you were to pass through this region, you could travel for a very long time without seeing any object large enough to be visible to the naked eye. Empty space does not exist only between planets. It exists within every object. Even Earth itself, the place you inhabit, is mostly empty space at the microscopic level. Between atomic nuclei and electrons are vast, empty regions. The solidity you experience is not true density, but the result of electromagnetic forces repelling one another. At cosmic scales, this becomes even clearer. The solar system is not a continuous mass of matter. It is a structure in which matter is compressed into small points, leaving most of space unoccupied. If you were to shrink the solar system down to a size that could fit within a city, most of that city would be completely empty. There would be nothing to collide with, nothing to block your view, only very small, very rare points acting as anchors of gravity. This is precisely what makes movement through space difficult, not because there are too many obstacles, but because there is nothing to hold on to. There are no continuous surfaces, no natural stopping points. Every movement must be calculated precisely, based on the gravitational influence of objects that are very far away. Empty space is also the reason the solar system has remained stable for billions of years. The planets do not need to avoid one another, because they rarely come close. Their orbits are maintained by a balance between motion and gravitational attraction. within a space large enough to prevent frequent collisions. If you were to stand anywhere in the solar system and look around, you would see nothing like the familiar illustrations. You would not see planets lined up. You would not see glowing rings. You would see darkness, a darkness that is not completely empty, but so diffuse that almost nothing stands out. Even light must cross this emptiness. Light from the central star takes more than 8 minutes to reach Earth. During those 8 minutes, it encounters no significant obstacles. It travels almost freely, through a space that is nearly entirely empty. This emptiness is not a deficiency. It is a condition of existence. Because of it, orbits remain stable. Because of it, energy can be distributed evenly. Because of it, a small planet like Earth can maintain a stable environment long enough for life to develop. Humans tend to fear nothingness. They fear emptiness. But at cosmic scales, nothingness is the foundation. Matter is only a rare byproduct, rising out of an ocean of emptiness. When this is understood, the way you view the solar system changes. It is no longer a system of worlds crowded around a star. It is a structure where empty space dominates, and matter exists only as rare markers within a vast expanse. Earth, in this picture, does not lie in a crowded neighborhood. It lies in a quiet region, far from other worlds, isolated by distances large enough to avoid constant disturbance, yet close enough to remain under the influence of the central star. Empty space does not make the solar system meaningless. On the contrary, because most of it is nothingness, what does exist becomes clear. A planet can maintain a stable orbit. A star can govern the entire system. And within such a vast emptiness, life has the opportunity to exist without being continuously disrupted. At this scale, the solar system is not built from objects. It is built from distances, from separation, from regions where there is nothing. And precisely because of that, everything else can remain in its proper place. I want to tell you about Earth from a different perspective, not through maps, not through borders, and not through the familiar numbers of population or surface area. I begin by shrinking it down, until everyday intuition can no longer maintain its role. Earth, as you experience it, is a vast world. Oceans stretch to the horizon. Mountain ranges take days to cross. Continents are separated by thousands of kilometers of water. A journey around the planet is rare, expensive, and usually exists only in imagination. From the surface, Earth appears almost limitless, but that perception is only valid at the scale of a human lifetime. When Earth is placed within the context of the solar system, its size begins to collapse rapidly. A diameter of more than 12,000 kilometers sounds immense, until it is set beside the hundreds of millions of kilometers separating the planets. Numbers that once carried meaning begin to fade. If Earth were shrunk into a sphere that could fit in your hand, the entirety of human history, every city, every ocean, every conflict, and every dream would lie upon a very small surface. At that scale, the differences humans consider profound nearly vanish. Even movement around Earth begins to change its meaning. A circumnavigation of the equator, once a journey lasting months, becomes a thin circle. Intercontinental flights, once regarded as technological triumphs, become short strokes on the surface. This shrinking does not make Earth less important. It simply clarifies that the meaning of size depends entirely on perspective. When Earth is placed within the surrounding space, the shift becomes even more pronounced. Earth does not reside in a crowded region. It moves through a space so vast that there is almost nothing nearby. The distances to neighboring planets are large enough that light takes minutes to cross them. During those minutes, there are no obstacles, no intermediate markers, only empty space. At this scale, Earth is no longer the center of a vast world. It becomes a small point, moving steadily, obeying laws it does not control. Familiarity disappears when viewed from afar. The details once important at the surface can no longer be distinguished. There are no blue oceans or brown continents. There are no national borders. There are no traces of human activity. Everything merges into a small, silent sphere, drifting in darkness. This is not a metaphor. It is how Earth truly exists in space. When shrunk further still, Earth gradually loses even its familiar form. It becomes a very small particle compared to the distances it must traverse in its orbit around the central star. That orbit is not a clearly defined circle, but a long curve, nearly straight when viewed at a sufficiently large scale. In that motion, Earth leaves no trace. There is no luminous trail. There is no sound. Only a very slow change of position within a coordinate system vastly larger than itself. When thinking about Earth in this way, many familiar concepts begin to lose their weight. Large and small are no longer absolute values. Far and near no longer resemble their meanings in everyday life. A distance once considered immense becomes insignificant when placed beside other scales. The shrinking does not stop at physics. It extends into how humans assess their own position. What was once considered central is now only a very small part of a larger structure. What was once considered the edge is now merely an arbitrary point in space. Even time begins to change in perception. A human lifetime, once considered long, becomes short when set against the age of the planet. The age of the planet, once considered long, becomes short when set against the history of the solar system. And the solar system, at an even larger scale, is only a moment in the flow of the universe. When Earth is reduced to its proper place, meaning no longer comes from size, it comes from something else, from the fact that on such a small sphere, within a vast expanse, conditions happen to converge to allow prolonged stability, temperatures just right, distance just right, time long enough. But in this part 3, what matters is not that uniqueness. It is the realization that Earth carries no cosmic meaning in terms of size. It is not large. It is not prominent. It does not dominate. The meaning humans assign to Earth is intrinsic. It exists because you are here, because every experience you have unfolds on this surface. When the planet is shrunk, what remains is not diminishment, but clarity. Earth does not need to be large to contain everything that matters to you. It only needs to exist at the right position, at the right distance, within a system that is mostly empty space. At the scale of the solar system, Earth is not a vast world. It is a very small anchor, suspended in space, and it is precisely this smallness that causes every familiar notion of large and small, familiar and distant, to begin losing its old meaning. When the human world is reduced to this scale, what remains is not a sense of loss. What remains is a more truthful picture of your real position, a position defined not by size, but by existence. I am telling you about the moon, not as a romantic symbol in the night sky, but as the first measuring stick that forces human intuition to recalibrate. In the solar system, you do not need to go far to encounter a shock about distance. Simply looking at Earth's only natural satellite is enough. The moon has always been familiarly present. It hangs in the sky, changes shape from night to night, governs the tides, and is tied to calendars, seasons, and ancient stories. Because it is so familiar, the distance between Earth and the moon is often underestimated. It looks close. It looks like something you could almost reach. But the real distance is not small. From the center of Earth to the center of the moon is nearly 400,000 kilometers. That number is difficult to grasp if you only read it aloud. To make it clear, it must be placed within more familiar frames of reference. Light, the fastest thing humans know, takes more than 1 second to travel from the moon to your eyes. When you look at that pale gray surface, you are seeing it in the past. 1 second does not sound long, but at astronomical scales, it is already a meaningful distance. Earth is not pressed up against the moon. They are separated by a region of space wide enough for light travel time to matter. The physical journey makes this even clearer. Flights that carried humans to the moon took several days, not because of a lack of technology, but because the distance truly exists. There is no shortcut, no detour, only an empty stretch that must be crossed through continuous motion. When Earth and the moon are placed side by side in a properly scaled model, familiarity disappears. Earth is no longer close to its satellite. Between the two bodies lies a gap large enough to contain many other things. In fact, if you were to line up all the other planets of the solar system, from tiny Mercury to massive Neptune, they would fit neatly into the space between Earth and the moon. Not cramped, not excessive, just right. That gap exists within the most familiar binary system you know. This forces intuition to change. If even the moon is that far away, then how vast must the other distances in the solar system be? But here, I stop at the moon, because it is the first shock. It is the closest. It is the most familiar. And for precisely that reason, it is the most effective at breaking the old way of seeing. The moon is not only distant in terms of space, it reveals something else as well. The solar system is not built from objects pressed tightly together. Even in the closest gravitational relationship, empty space still dominates. If you stand on Earth's surface and look up, the moon has a very small angular size. It is just large enough to cover the central star during solar eclipses. This coincidence has led many to believe there is something special in the universe's arrangement. But when examined in terms of distance and size, it is simply the result of coincidental ratios. The moon is much smaller than Earth, but because it is far enough away, it appears with just the right apparent size. Distance creates the illusion of symmetry. Distance also clarifies isolation. The moon has no thick atmosphere, no oceans, no surface life. It exists as a separate world. Even though it is gravitationally bound to Earth, connection does not mean closeness. If you move farther away still, Earth and the moon begin to merge into a tiny binary system. The space between them becomes more obvious, while the two bodies themselves shrink. From that perspective, a relationship once considered intimate becomes a minor detail within a vast expanse. This distance also reveals the limits of human experience. In everyday life, a few hundred kilometers already feels far. A transcontinental journey is an event. But in an astronomical context, a few 100,000 kilometers is only the first step. It is the smallest scale that forces you to expand the way you think. The moon, therefore, is not just a satellite. It is the first lesson in true scale, a lesson that unfolds above your head every night, yet is rarely recognized. When the Earth-Moon distance is placed in its proper context, many things begin to change. Familiar images lose their persuasive power. A sense of closeness gives way to precision. And from that precision, the picture of the solar system becomes entirely different. Here, empty space is not meaningless emptiness. It is the space required for orbits to remain stable. It is the reason the moon does not fall into Earth, and Earth does not pull the moon into a chaotic path. Distance creates order. When you accept this, the moon is no longer a nearby, hovering object. It becomes a measuring marker, a marker showing that even what seems closest is separated by nothingness. And once this first shock is accepted, every other distance in the solar system begins to appear as it truly is, not as gaps that imagination can easily fill, but as vast empty regions, where matter appears only as rare exceptions. I am telling you about the sun in the least noticed way, not as the blinding light in the daytime sky, and not as the familiar symbol of life. What determines every movement in the solar system does not lie in appearance, but in mass, in the silent authority of an object that contains nearly everything that exists around it. The sun does not sit at the center because it was placed there. It is at the center because its mass forces everything else to revolve around it. Nearly all the matter of the solar system is contained within a single sphere. All the planets, moons, asteroids, and cosmic dust combined account for only a very small remainder. Order does not need to be declared. Order emerges as an inevitable consequence. When viewed from Earth, the sun appears just large enough to dazzle the eyes, and just distant enough not to threaten. Distance creates a sense of safety, but when the solar system is scaled correctly, the size of the sun begins to shatter intuition. It is more than 100 times wider than Earth. Its surface is large enough to place Earth upon it thousands of times and still leave room to spare. Mass is the crucial point. The sun's weight is so great that every orbit must obey it. No contact is required. No collision is required. Mere existence is enough. Gravity spreads through space, bending the paths of all smaller bodies. The planets are not pulled inward violently. They fall forever, but sideways, forming stable orbits within a vast emptiness. This power is not loud. It does not produce chaotic spectacles. It maintains regularity. Each revolution repeats. Each year passes. Each distance is preserved for billions of years. The order of the solar system is not maintained by force, but by the absolute dominance of mass. Inside the sun, matter does not remain still. Temperatures and pressures are so extreme that atomic nuclei fuse together. Every second, a small amount of mass is converted into energy. One does not need to understand the detailed process to grasp its consequence. Energy is released continuously, spreading in all directions, crossing immense empty space to reach the planets. Only a very small fraction of it reaches Earth. But that is enough. Enough to melt ice, generate winds, drive the water cycle, and maintain temperatures that allow liquids to exist on the surface. Life does not require abundance. It requires long-lasting stability. The power of the sun, therefore, has two sides. On one side, it holds the planets in their proper places, preventing the system from collapsing into chaos. On the other, it provides a steady flow of energy, neither too strong nor too weak. There are no crescendos, no interruptions, only persistence. If you were to stand on the surface of the sun, familiar concepts of space would distort. The horizon there would be far more distant than on Earth. The surface would curve gently, stretching across your field of view. But it is not a place to stand. There is no ground, no clear boundary, only hot matter in constant motion, rising and sinking in enormous convection currents. Yet what is remarkable is not that violence. It is the fact that, from Earth's distance, everything unfolds in silence. Light arrives steadily, heat arrives steadily. There is no sign that the interior is an extreme environment. Distance once again plays its role, transforming chaos into stability. The sun does not need to occupy much space to dominate the solar system. It only needs to occupy mass. In a structure where most of existence is empty space, an object this heavy becomes the natural center. There is no competition. No other body is strong enough to challenge it. This also explains why small planets never control the system. They are locked into their orbits not because they are weak, but because order was established from the beginning. When the solar system formed, most of the matter fell into the center. What remained was forced to arrange itself around it. This silent order persists across immense spans of time. Billions of years pass while Earth's orbit changes only slightly. The average distance remains stable. Seasonal rhythms repeat, not because anything is being actively adjusted, but because the central mass does not change rapidly. When the sun is viewed this way, it is no longer merely a source of light. It becomes the invisible foundation of every experience on Earth, every day and night. Every biological cycle, every familiar rhythm of time is bound to a distant sphere, governing through its own weight. In a solar system where empty space dominates, the sun is the only anchor strong enough. It does not need to be close. It does not need to intervene. It only needs to exist, and in that existence, order is maintained. When the sun is placed in its proper position within this picture, everything becomes clearer. The solar system does not operate because of the planets. It operates because of an overwhelming central mass, keeping all motion silent, regular, and stable long enough for a small planet like Earth to exist. I am telling you about the 4 rocky planets not as friendly destinations, but as direct consequences of position and material. They lie closer to the sun than any other planets. There, temperatures are high, radiation is intense, and only the most resilient materials can survive. Metal and rock form the worlds. Light gases were stripped away very early. These planets carry clear traces of a harsh formation. The 4 planets are Mercury, Venus, Earth, and Mars. They are often grouped together under a neutral name, the rocky planets. But their similarity almost entirely ends with material structure. Surface conditions on each world differ so profoundly that they cannot be confused. Mercury lies closest to the sun. Its short distance subjects it to intense radiation. Mercury's surface resembles a world laid bare. There is no significant atmosphere to retain heat or provide shielding. During the day, temperatures soar to levels where metals can soften. At night, temperatures plunge to extreme lows. This contrast is not an exception. It is the normal state. Time on Mercury also operates in an unfamiliar way. A single day lasts longer than a year. The planet rotates slowly while racing rapidly around the sun. Light moves across the surface as an extended process, without a steady rhythm. There is no familiar sunrise, no gentle sunset, only extreme change. Mercury shows what happens when a planet is too close to its star. There is no protective layer, no balance. Only exposed material and endlessly stretched time. Venus lies farther out, but it is no gentler. Venus is close to Earth in size. This once led people to imagine a similar world, but Venus's surface stands as proof that size does not determine habitability. Venus's dense atmosphere traps heat without mercy. Surface temperatures are high enough to melt lead. Pressure is many times greater than on Earth. If you could stand there, your body would be crushed before you could even feel the heat. Venus rotates backward. The sun rises where it would set on Earth. Time on Venus is distorted as well. A single day is longer than a year. Light moves slowly through a sky choked with acidic clouds. There is no familiar cycle for life to rely on. Venus shows what happens when a planet retains too much gas. The greenhouse effect runs out of control. Heat cannot escape. Every balance collapses. The world becomes a vast furnace, stable in a lethal way. Earth lies between these two extremes, not close enough to be scorched, not far enough to freeze completely. But position is only part of the story. Earth retains an atmosphere that is just right. Not too thick, not too thin. Pressure is moderate. Temperatures allow water to exist in liquid form. This stability is not obvious when viewed from space. It is the result of many coincidental factors. Enough mass to hold on to gas, a suitable distance to avoid a runaway greenhouse effect, an active surface that recycles material over long timescales. These conditions are not common among the 4 rocky planets. When Earth is placed beside Venus and Mercury, the difference becomes unmistakable. Earth is not the standard. It is the exception. Mars lies farther out. Light is weaker. Temperatures are lower. This planet once had water on its surface. The evidence remains. Ancient flow channels, dry valleys. But Mars is small. Its mass was insufficient to retain a thick atmosphere for long. The solar wind gradually stripped away its protective layer. Today, Mars is a cold, dry world. Average temperatures are low. Pressure is too weak for liquid water to persist. The surface bears the red color of oxidized iron. Massive volcanoes stand frozen in silence for billions of years. Vast valleys recall a wetter past that has vanished. Mars shows what happens when a planet cannot retain internal energy. Strong geological activity fades. Protective magnetic fields disappear. The world slowly cools and falls silent. These 4 rocky planets form a clear progression as you move outward from the sun. Heat decreases. Radiation weakens. The ability to retain gas changes. There is no sharp boundary. Only a gradual transition, with decisive consequences. When you look at these 4 worlds, you do not see the kindness of the universe. You see physical conditions operating neutrally, without bias, without favor. Each planet is the result of its own position, mass, and history. Harshness is not unusual. It is the default state. Earth is not evidence for the abundance of life. It is evidence for the rarity of balance. In the region near the sun, where rock and metal dominate, even a small deviation is enough to produce an entirely different world. Mercury is too close. Venus holds too much gas. Mars is too small. Earth lies in a fragile gap between them. The 4 rocky planets are therefore not merely separate worlds. They are a natural experiment spanning billions of years, showing different outcomes from the same initial ingredients: rock, metal, gravity, and radiation. No intention, no purpose, only consequences. When you place them side by side, you begin to see the fragility of what feels familiar. Earth does not represent rocky planets. It is the exception within a group that is largely harsh and inhospitable. These 4 planets orbit an ordinary star. There is no exceptional violence, nothing remarkable compared to billions of other stars. Yet distance and mass alone are enough to create 4 entirely different worlds. And within those differences, you see clearly how the solar system operates. Not through promises, not through hope, but through quiet laws, extended over time. And without compromise, I am telling you about one of the most misunderstood regions of the solar system. It is not a dense wall of rock. It is not a deadly corridor filled with constant collisions as popular imagination suggests. The asteroid belt, in reality, is a vast expanse of space where matter is so sparse that silence becomes its defining feature. This belt lies between the orbits of Mars and Jupiter. That location is not an arbitrary boundary. It marks the region where the process of planet formation was disrupted very early on. What remains are not fragments of a destroyed world, but the remnants of a world that never had the chance to fully form. If you were to fly through the asteroid belt, you would not see rocks drifting close together. Most of the time, you would see nothing at all. The distances between asteroids are so great that the probability of colliding with one is extremely low. This is not a debris field. It is a sparse archive of primordial material. Asteroids in the belt vary greatly in size. Most are small, rocky bodies, ranging from a few meters to a few kilometers across. Only a small number reach sizes large enough to draw attention. Among them, Ceres is the largest object. It is large enough to assume a nearly spherical shape and is classified as a dwarf planet. Yet even Ceres is far smaller than any of the rocky planets. What matters is not the size of individual objects, but the total mass. If all the material in the asteroid belt were gathered into a single body, its mass would still amount to only a small fraction of the Moon's mass. Not enough to form a planet, not enough to bind itself together with strong gravity. This leads to a clear conclusion. The asteroid belt is not the remains of a planet that was blown apart. It is material that was never allowed to merge. The reason lies with Jupiter. This giant gas planet sits just beyond the belt. Jupiter's mass is so large that its gravitational influence extends deep into the surrounding region. In the early stages of the solar system, when fragments of rock and metal were attempting to stick together, Jupiter's gravity continually disrupted the process. Pieces of material collided, but instead of merging stably, they were often pulled off course, torn apart, or pushed into chaotic motion. The process of accretion was broken again and again. There was never enough quiet time for a complete planet to emerge. The asteroid belt is therefore a region of failure in a physical sense, not a tragic failure, simply the result of gravitational competition. There, Jupiter prevailed before a rocky planet could form. Asteroids carry within them an ancient history. Most never underwent large-scale melting or restructuring like planets did. This makes them nearly pristine samples of the original material from which the solar system formed. They are like fragments of time frozen in place. The surfaces of many asteroids preserve the marks of billions of years of impacts. There is no atmosphere to erase the scars, no plate tectonics to renew the surface. Each crater is a silent record of a distant past. Among asteroids, there are many different types. Some are rich in carbon, dark and porous. Some are rich in metals, especially iron and nickel. Some contain minerals that once interacted with water. This diversity reflects the distribution of heat and material within the early protoplanetary disk. Metal-rich asteroids may be the cores of small bodies that began to differentiate but were shattered by collisions before completion. Carbon-rich asteroids may carry simple organic compounds, key ingredients in prebiotic chemistry. This transforms the asteroid belt from a meaningless region into a natural data archive of how the solar system formed. Each asteroid is a fragment of a record, preserving the physical conditions at the moment of its birth. Some asteroids do not remain within the belt. Over time, gravitational interactions with Jupiter and other planets can push them into new orbits. Some are ejected from the solar system entirely. Others are driven inward, becoming near-Earth asteroids. From this point, the connection between the asteroid belt and Earth's history becomes clear. Many meteorites that fall to Earth originate from this region. They carry ancient material, sometimes containing water and organic compounds. Past impacts may have helped deliver the ingredients necessary for life to the surface of the young Earth. The asteroid belt is therefore not merely a forgotten region. It is a bridge between the formative past and the stable present. It shows that not every region of the solar system followed the same evolutionary path. Between small Mars and massive Jupiter, there was no room for a mature rocky planet. There are only quiet fragments drifting along, preserving their original state for billions of years. When you view the asteroid belt this way, it no longer appears as a dangerous void. It becomes a natural museum, where the exhibits are not arranged or labeled, but simply exist. There are no signs, no pre-written stories, only matter, orbits, and time. The asteroid belt reminds you that the solar system was not perfectly designed. It formed through complex interactions, where some things succeeded and others were left unfinished. No planet was destroyed here. There was only a planet that was never born, and in that incompleteness, you see more clearly how the universe operates, not by intention, not by script, but through invisible forces that quietly determine what is allowed to exist and what remains forever, an unrealized possibility. I am telling you about Jupiter as a second central structure, not because it shines, but because it governs. Once you move beyond the asteroid belt, the order of the solar system changes noticeably. Distances between objects widen. Mass concentrates into a single entity. Jupiter emerges as a physical boundary where familiar intuitions about planets begin to lose their validity. Jupiter is not like Earth, nor like any rocky planet. It has no solid surface to stand on. There is no clear boundary between atmosphere and interior. What exists instead are layers of material that grow denser with depth, under continuously increasing pressure. This is a world of hydrogen and helium, light elements compressed until they become unfamiliar. Jupiter's size defies ordinary comparison. Its diameter is many times that of Earth. Its volume is large enough to contain more than 1,000 Earths inside, with room to spare. But the more important number is mass. Jupiter is so massive that the combined mass of all the other planets still does not equal it. In the gravitational balance of the solar system, Jupiter stands second only to the Sun. It is this mass that turns Jupiter into a secondary center. It does not shine. It does not generate energy for life. But it is strong enough to bend orbits, capture moons, and shape its surroundings. If the Sun is the main axis, Jupiter is the largest gear transmitting force throughout the system. Surrounding Jupiter is a vast system of moons, not a few scattered satellites, but dozens of distinct worlds, each with its own physical characteristics. Seen from afar, Jupiter and its moons resemble a miniature planetary system, rotating around a common center. Among these moons, 4 large ones stand out like independent planets. One is a world of constant volcanic activity, where the surface is endlessly reshaped by energy from gravitational stretching. Another is an icy world with a smooth surface, concealing a liquid ocean beneath. Another is larger than Mercury, with enough mass to generate its own magnetic field. And another is an ancient world, heavily cratered, preserving the history of billions of years. This diversity is not accidental. It is a direct consequence of Jupiter's immense gravity. The moons do not merely orbit their parent planet. They interact with one another, are stretched, compressed, and heated from within. Energy does not come from sunlight, but from orbital motion and tidal forces. Here, life does not require strong light to be considered. It needs only liquid water, energy, and time. Those conditions can exist in darkness, beneath thick ice, sustained by the constant stirring of gravitational forces. In this way, Jupiter is not merely a giant gas planet. It is an indirect energy engine for the worlds around it. Jupiter itself is not still. Its visible surface consists of swirling cloud bands in constant motion, storms that last for centuries. A massive vortex large enough to engulf Earth, winds blowing at speeds far beyond any storm on Earth. Yet all of this unfolds within a stable, repeating order. Like a system that has found its own equilibrium, Jupiter rotates very rapidly. A single day lasts less than 10 hours. This rapid rotation causes the planet to bulge at the equator, giving it a shape that is not perfectly spherical. This is not an aesthetic detail. It reflects the internal distribution of mass and dynamics, where matter moves continuously under enormous pressure. Jupiter's role in the solar system extends beyond its many moons. Over the long history of the system, Jupiter has strongly influenced the orbits of countless small bodies. It acts both as a shield and as a disturber. Many asteroids and comets have had their paths altered by Jupiter's gravity, some flung outward, others hurled inward. There is no intention in this process, only gravity operating according to its laws. But the consequence is that the inner solar system has become more stable over time. Jupiter, with its overwhelming mass, has shaped the rhythm of impacts, indirectly influencing the history of the rocky planets. When you view Jupiter as a miniature solar system, you begin to see repeating structure. A massive central body, smaller objects orbiting around it, Energy distributed through motion, order maintained not through stillness, but through dynamic balance. Jupiter shows that a planet does not need to resemble Earth to be important. Its value lies in its structural role, not in its ability to nurture life on its surface. It is an essential component of the overall architecture, keeping the solar system operating in the way we recognize today. In a vast space where emptiness dominates, Jupiter is a heavy anchor, pulling everything toward order. It does not speak. It does not consciously intervene. It simply exists. And in that existence, it creates a complete subsystem, quietly rotating, as a demonstration of how mass and gravity can build an entire complex world from simple ingredients. I'm telling you about places where there is no sunrise. There, sunlight barely reaches the surface. Heat does not come from the sky. And if life exists, it does not need to see day or night. Ocean moons force you to revise a familiar assumption. Life does not necessarily have to live on the surface, and it does not need light in order to begin. These worlds orbit giant planets. Their distance from the sun is great. Their surfaces are icy cold, covered by thick ice. From far away, they look like silent, dead spheres. But beneath that ice, water can exist in liquid form for very long periods, not because of light, but because of gravity. Gravity does not only hold moons in orbit, it continually stretches and compresses them. When a moon orbits its parent planet on a slightly elongated path, the pull changes with position. The material inside is rhythmically deformed. Friction generates heat. That heat does not explode outward, but accumulates, enough to keep water from freezing completely. This mechanism is called tidal heating. It turns orbital motion into internal energy. In darkness, beneath tens of kilometers of ice, an ocean can exist, quiet and stable. No sun required, no seasons required. One such moon has a smooth, icy surface with almost no large impact craters. This suggests the surface is continually renewed. Ice cracks, rises, and freezes again. Beneath it, a global ocean may be deeper than all of Earth's oceans combined. The water there contacts rock, a crucial condition for complex chemical reactions. On another moon, the surface is smaller but unexpectedly active. From fractures near the poles, columns of water vapor and ice particles erupt straight into space. This indicates that the ocean below not only exists, but communicates with the surface. The ejected particles carry salts and simple organic compounds. There is no need to drill through ice to know this. The ocean reveals its own presence. These discoveries change how you think about habitable environments. In the past, life was often tied to being at just the right distance from a star. Suitable temperatures, liquid water on the surface. But ocean moons show another path. Liquid water can be retained by orbital energy. Heat can come from within. Light is no longer a mandatory condition. On Earth, life does not exist only because of light. On the deep ocean floor, where light never reaches, ecosystems still thrive around hydrothermal vents. There, energy comes from chemical reactions between water and hot rock. Microbes use chemical energy instead of solar energy. This is not a hypothesis. It is happening right now. When you place those ecosystems alongside ocean moons, the similarity becomes clear. Liquid water, a stable energy source, long timescales. These three factors are enough for simple life to appear and persist. No blue sky required. No sunlight required. Ocean moons are more diverse than you might think. Some are large enough to have their own magnetic fields, shielding internal oceans from radiation. Some contain lakes of liquids other than water on the surface, while liquid water lies far below. In some places, the ocean is trapped between an upper ice layer and a lower ice layer, creating different environmental strata. What matters is time. These oceans could persist for billions of years, not boiling away, not freezing solid. Over that span, chemistry has enough opportunity to become complex. Life does not need speed. It only needs enough time. Of course, there is no direct evidence that life exists there. No organism has been seen. No clear signal has been detected. But absence of evidence is not evidence of absence. These environments are difficult to access. Thick ice conceals everything beneath. Great distance makes exploration slow. Even so, Indirect signs are enough to keep the question open. Suitable chemistry, continuous energy sources, stable liquid water. This is not a random list. These are the minimal conditions that life on Earth has exploited. Ocean moons force you to expand the concept of the habitable zone. It is no longer a thin band around a star. Instead, it becomes hidden pockets of environment sustained by orbital dynamics. Life, if it arises, could live in permanent darkness, never knowing surface light at all. This also changes how you think about the prevalence of life in the universe. If light is no longer a strict requirement, the number of potentially habitable places increases dramatically. Every giant planet with a rich moon system becomes a cluster of opportunities. Not one world, but many potential worlds. In the solar system, ocean moons are not at the center. They orbit planets that do not shine. They exist in darkness. Yet it is precisely there that the most basic conditions for life may be maintained quietly. When you think about life this way, you no longer search for familiar surfaces. You begin to think of buried oceans, slow chemical reactions, ecosystems that do not need a sky. Life, if it exists, does not have to resemble anything familiar. Ocean moons remind you that the universe has no obligation to match human intuition. Physical laws allow many different pathways, and in the cold darkness, beneath thick ice, there may exist worlds where life does not need surface light to begin. I am telling you about 3 worlds that lie beyond Jupiter, where the solar system becomes unfamiliar in a different way. Sunlight grows weaker, temperatures drop sharply, time seems to move more slowly. Here, planets are no longer defined by solid surfaces or thin atmospheres, but by enormous, complex structures that are difficult to grasp with intuition. Saturn appears first. It is not the largest planet, but it is the most recognizable. Saturn's ring system is vast, delicate, and intricate. From a distance, it feels like an architecture designed with intention. In reality, it is the result of gravity and collisions, repeated over immense spans of time. The rings are not solid, continuous sheets. They are composed of countless fragments of ice and rock, ranging from tiny grains of dust to blocks as large as houses. Each fragment orbits Saturn along its own path, obeying precise laws. There is no cohesion, no fixed structure, only motion sustained by gravity. Saturn itself is a gas giant. It is composed primarily of hydrogen and helium, with a density so low that, if there were an ocean large enough, it could float, but that lightness is deceptive. Saturn's mass is still great enough to dominate a rich system of moons and to sustain a powerful magnetic field. Inside Saturn, matter does not exist in familiar forms. Pressure rises rapidly with depth, forcing hydrogen into a metallic state, flowing. Electrically conductive material generates a magnetic field, wrapping the planet in an invisible shield. The visible surface is nothing more than moving cloud layers, concealing the deep internal structure. If Saturn represents architectural elegance, Uranus represents deviation. This planet rotates with its axis tilted almost sideways relative to its orbital plane. This tilt is not a minor detail. It shapes the planet's entire climate and temporal rhythm. On Uranus, each pole experiences many consecutive years of sunlight, followed by many years of darkness. There is no familiar day-night cycle. Light is distributed unevenly across seasons that last for decades. The atmosphere responds slowly, creating a world that appears calm, while beneath the surface complex motions persist. Uranus belongs to the class of ice giants, not because it is made of ice in the everyday sense, but because its interior contains large amounts of substances such as water, ammonia, and methane under high pressure. These materials do not freeze as you might expect. They exist in strange phases, neither purely liquid nor solid. Under extreme temperatures and pressures, methane in the atmosphere absorbs red light, giving Uranus its pale blue-green color. This color is not decoration. It is a signal of chemical composition and atmospheric structure. Even color is physical data. Neptune lies even farther out. Sunlight reaching it is faint. Yet paradoxically, it is one of the most dynamic planets in the solar system. Winds blow at speeds exceeding those anywhere else. Giant storms form and dissipate over relatively short timescales. Neptune is also an ice giant. similar in composition to Uranus, but its internal energy is greater. Heat escapes more vigorously from its interior, driving violent atmospheric motion. Here, great distance does not equate to stillness. Neptune's internal structure is complex and not yet fully understood. The outer atmosphere conceals a thick layer of fluid, beneath which lies a core of rock and metal. There are no sharp boundaries, only gradual transitions from light to heavy, from cold to hot. These three planets reveal different paths that giant planets can take. Saturn, with its fragile rings, Uranus, with its tilted axis, Neptune, with its violent atmosphere. There is no single model, no standard design. They also show that large size does not mean simplicity. The larger the planet, the more complex its structure. The farther from the Sun, the more diverse the energy sources become. Sunlight is no longer the sole dominant factor. Internal heat, dynamics, and chemical composition grow more important. These giant planets play an architectural role in the solar system. They are not merely isolated objects. They shape the orbits of smaller bodies. They hold and organize moon systems. They create regions of stability and instability, influencing the entire surrounding structure. When you look at Saturn, Uranus, and Neptune, you do not see places where one could stand. You see immense masses of matter, operating under laws far removed from everyday experience. There is no surface to grasp, no familiar horizon, only layers of gas, ice, and fluid stacked within a dynamic order. These worlds remind you that the solar system is not a sequence of similar planets arranged by size. It is a collection of distinct architectures, each one the result of position, mass, and formation history. In the outer regions, where light fades, diversity does not diminish. It merely changes form. Giant planets become more abstract structures, less connected to human experience, yet more revealing of how matter organizes itself when given sufficient space and time. In the strangeness of Saturn, Uranus, and Neptune, one consistent truth emerges. The universe does not favor familiarity. It allows many architectures to coexist, and the solar system, in these distant regions, becomes far richer and more unpredictable than initial intuition would ever suggest. I am telling you about an experiment that seems simple. Put the solar system onto an Earth map to make it easier to imagine. Shrink everything by the same scale. Then use familiar place names as reference points. This idea is often used to help people understand distance. But very quickly, you will realize one thing. Even metaphor has limits, and at a certain point, it begins to fail. Start by shrinking the central star into something familiar. Suppose it is only as large as a ball placed at the center of a city. Then the third planet, the one you live on, would not be in the same neighborhood. It would not be at the end of the street. It would be far away, so far that you would have to place it in a different district, dozens of kilometers away. And between those 2 points, your map would be almost empty. On a map, those empty stretches are often filled with symbols, colors, or annotations. But in the real solar system, they are not filled. They exist as regions of space that contain almost nothing. When you translate this onto an Earth map, you are forced to draw roads, draw markers, draw boundaries. And that is where distortion begins. If you keep placing the other planets on the map, the problem becomes even clearer. The rocky planets lie scattered, each separated by distances far beyond ordinary experience of travel, journeys that on Earth would take a few hours by plane. In this model represent only very small distances in the solar system. The map begins to stretch and compress reality to fit the page. By the time you place the giant planets, the map nearly loses its function. Distances are no longer comparable to any familiar landmark. You would have to draw a straight line through multiple countries, across oceans, over continents, just to represent an empty span between two orbits. And even then, you would still be shrinking too much. Here, the metaphor is not wrong, it is simply insufficient. An Earth map is made to serve surface movement, roads, seas, air routes. It assumes that distance always comes with terrain, obstacles, environmental change. But in the solar system, distance comes with nothing at all. No mountains, No rivers, no borders, only empty space. When you try to assign those empty regions onto an Earth map, you are forced to imagine what does not exist. Invisible roads, journeys without scenery, stretches without landmarks. A map, built on connecting points of meaning, becomes out of place when faced with a structure whose meaning lies in emptiness itself. Even time betrays the metaphor. On Earth, distance is often proportional to travel time. Farther means longer. But in space, this is only true when you tie it to a specific technology. There is no default speed, no shared rhythm. Light takes a few minutes to travel from the center to your planet, but an artificial object takes many months. A map cannot convey that disparity. When you place the solar system onto an Earth map, you also encounter another problem: size. If you keep distance to scale, the sizes of the planets become too small to see. They turn into unnamed dots. If you enlarge them to be visible, distance is immediately distorted. You are forced to choose one or the other, and either choice causes part of the truth to be lost. It is here that you see the limit of intuition. Intuition needs images. It needs comparisons. It needs metaphor. But the solar system is not built to match human intuition. It is built by laws that do not care whether you can visualize them. An Earth map is a product of closeness. It assumes every point can be related to lived experience. But when you try to place the solar system onto it, lived experience is no longer wide enough to serve as a frame of reference. The numbers exceed feeling. The emptiness exceeds imagination. This does not make maps useless. It only shows that a map is not reality. It is a tool, and every tool has limits. When you exceed those limits, the tool no longer reflects the structure it is trying to describe accurately. The solar system, seen from this angle, is not a place you can walk across. It is not a network of locations. It is a dynamic structure in which distance matters more than position, and emptiness matters more than objects. When metaphor begins to fail, you are forced to accept a different way of seeing, no longer relying on maps, no longer relying on familiar comparisons, only numbers, ratios, and the acceptance that some structures exist beyond the natural human ability to visualize. This does not make the solar system more alien. On the contrary, it makes you see it more truthfully, not through the lens of cities, countries, or journeys, but as a system where empty space is the main component, and worlds are only rare points marking the presence of matter. When you place the solar system onto an Earth map, you learn an important lesson, not about geography, but about perception, that there are structures in the universe that cannot be compressed into human experience without trading away accuracy. And once you accept that, you stop trying to force the solar system into familiar molds. You begin to let it exist at its true scale, vast, empty, and challenging every attempt at simplification. I am telling you about something that happens continuously, yet is rarely noticed. Every time you look up at the sky, you are not seeing the present. You are seeing the past. Not the distant past in the sense of memory, but the physical past, recorded and transmitted by light. Light does not arrive instantly. Even though it is the fastest thing in the universe, it still requires time to travel. And it is precisely this travel time that creates an unavoidable phase offset between an event and your observation of it. This offset is negligible in everyday life, but becomes decisive when extended across space. From the central star to Earth, light takes more than 8 minutes. When you feel warmth on your skin or see daylight, you are responding to a state that existed 8 minutes earlier. If anything were to change at the center of the system, you would not know immediately. Information always arrives late. This delay is not a technical detail. It is the foundation of how you perceive the universe, even within the most familiar range. Light travel time is already present. Light from the moon takes more than 1 second to reach your eyes. When you look at that pale gray surface, you are seeing it as it existed more than a second ago. That number may sound small, but it is enough to confirm that a direct present does not exist in astronomical observation. As you extend outward to other planets, the delay increases rapidly. Light from the nearest planets takes several minutes. From more distant planets, it takes tens of minutes. Every image you see is a slice of time, not an instantaneous state. The solar system, therefore, is not a structure you see all at once. It is a collection of different moments, stacked together in perception. When you look at a planet and compare it with Earth, you are placing two different moments side by side and calling them the present. This confusion is easy to fall into because the human brain evolved to handle extremely small delays. In everyday life, light arrives so quickly that you can ignore its travel time. But the universe does not operate on the scale of human experience. When you look farther still, light travel time becomes impossible to ignore. A star a few light years away is seen as it existed a few years ago. A galaxy millions of light years away is seen as it existed when humanity had not yet appeared. The night sky is not a picture of the present. It is a time archive. Each point of light is a message sent from the past. Some messages are very near. Some are very distant. Some come from events that no longer exist. You may be seeing the light of a star that died long ago. The light continues its journey, regardless of whether its source has vanished. This changes how you understand observation. You do not observe the universe as it is. You observe the universe as it was, and there is no alternative. No shortcut. No technology can overcome this limit, because the limit does not lie in the instruments. It lies in the structure of space and time. Light travel time also clarifies the role of emptiness. Light passes through nearly empty regions for immense durations, unobstructed, not significantly slowed. It is precisely this emptiness that allows information from the past to be preserved and transmitted. Within the solar system, light delay produces a subtle effect. Events are not perfectly synchronized. When you see a planet at a given position, it has already moved further along its orbit while the light was traveling to you. Every map must correct for this. Every measurement must account for the delay. Even radio signals, which also travel at the speed of light, obey the same limitation. When a signal is sent, the reply does not arrive immediately. The silence between the two ends is not due to a lack of response, but to the time required for information to cross empty space. Light travel time also forces you to reconsider the concept of the present. The present, in the universe, is not a single shared moment for all locations. It is a local concept. What is present for you is not present for a place millions of kilometers away. The universe does not share a single clock. When you look at the sky, you are looking through multiple layers of time at once. A planet at one moment, a star at another, a galaxy at a far more distant moment. All appear within the same frame, but they do not exist within the same instant. This does not make the sky less real. It makes it deeper. Each ray of light carries a story that has already happened. Each distance is a span of time wrapped into motion. Light travel time turns the universe into a natural archive. No recording devices are required. No artificial storage is needed. Space itself preserves the past and carries it forward. You only need to look. Within the solar system, the time differences are small, but when you look farther out, you begin to see the philosophical consequences clearly. You cannot observe the universe without observing the past. Perception and time are inseparably linked. Once you understand this, you no longer think of the sky as a stage where events are unfolding. You think of it as a recording being played back continuously, at different speeds, from different distances, and within that playback, your present is only a very small point, where signals from countless pasts converge. You stand there, not at the center of space, but at the center of a temporal intersection. Light travel time is not a barrier that makes the universe distant. It is the mechanism that makes the universe observable. Because of it, the past does not disappear. It continues to exist as light, flowing through space, waiting to be seen. When you lift your eyes, you are not only looking far away, you are looking backward in time. And this happens every night, quietly, without explanation, as an inseparable part of reality. I am telling you about space travel in the least romanticized way, not as instantaneous jumps, not as journeys that cross distance in the blink of an eye. Travel within the solar system is a story of limited speed and extended time. Here, patience is not a moral quality, it is a physical condition. In space, there are no roads. There is no ground to push against through friction. Every motion must be paid for with energy. And when energy is limited, speed becomes something that must be weighed carefully. You cannot simply accelerate and go straight. You must accumulate velocity bit by bit, and every bit carries consequences. The first limit does not lie in technology. It lies in physics. To accelerate an object with mass, you must push it. That push comes from throwing other mass backward. Fuel, therefore, is not just an energy source. It is mass you must carry. The more you want to go fast, the more you must carry. And the more you carry, the heavier you become. This is the basic loop of space travel. Even leaving Earth, the hardest part has already happened. Escaping the planet's gravity requires sufficient velocity. There is no shortcut, no compromise. Once you have left, you are not truly flying fast. You are simply falling around the central star along a different orbit. In space, speed is not felt the way it is on Earth. There is no wind, no sound. A spacecraft can move at tens of thousands of kilometers per hour and still experience absolute silence. Motion is perceived only through the slow change in the positions of stars. The distances in the solar system cause intuition to collapse. Even when moving at speeds that are enormous by human standards, journeys still take months, sometimes years, not because the spacecraft is slow, but because space is vast. To travel farther, humans have learned to borrow momentum. Giant planets become natural acceleration stations. When a spacecraft flies past them, it exchanges energy with the planet, changing direction and increasing speed without additional fuel. But the price is time. Orbits must be calculated precisely. Timing must be exact. There is no room for haste. Space travel is therefore the art of waiting. Waiting for planets to be in the right position, waiting for trajectories to open, waiting years for an acceleration that lasts only hours. Patience is not optional. It is the inevitable consequence of respecting the laws of nature. Even signals do not escape this reality. Every command sent must wait for a response. As distance increases, waiting lengthens. Real-time control becomes impossible. Humans must learn to program autonomy, allowing spacecraft to make decisions on their own during long intervals of silence. Space travel is also a lesson in biological limits. The human body did not evolve to endure prolonged weightlessness. Bones gradually lose density. Muscles weaken. The circulatory system changes. Time becomes a challenge as serious as distance. In deep space, everything happens slowly. There are no rapid sequences of events, no clear natural time markers. Day and night lose their meaning. Only technical cycles and artificial schedules are created to maintain rhythm for humans. The greatest speed limit does not lie in engines. It lies in the impossibility of exceeding the speed of light, not because humans lack ingenuity, but because the structure of space and time does not allow it. Information, energy, and matter are all bound by the same limit. This means every journey must accept delay. There is no instantaneous observation, no immediate rescue. Every decision must be made with the awareness that consequences will arrive late and cannot be corrected instantly. Within the solar system, this limit is not yet an absolute barrier, but it is sufficient to shape how humans approach space, not through haste, but through long-term planning, through accepting that some journeys will last longer than a human lifetime. Space travel, therefore, is not a story of rapid conquest. It is a story of endurance, of maintaining systems over long durations without error, of trusting calculations performed many years earlier. When you imagine a spacecraft leaving Earth, it does not surge forward as it does in films. It separates slowly, accelerates gradually, then continues drifting in silence. Each passing day adds very little distance compared to the total journey. Yet it is precisely that accumulation that creates motion. Patience here is not passive waiting. It is active endurance. It is keeping everything functioning steadily over time without immediate reward. There are no spectacular scenes, only repeated precision. Space travel also exposes the gap between desire and capability. The desire is to go fast. Capability forces slowness, not because of a lack of will, but because the laws cannot be negotiated. In this context, every kilometer gained is the result of many careful choices. Every hour of flight is the result of prolonged preparation. There are no easy leaps, only long, steady curves. When you understand space travel this way, you no longer ask why humans move slowly. You begin to see that moving slowly is the only way to go far. Space does not reward haste. It rewards systems that can outlast human impatience, and in that extended silence, space travel becomes a test of time. Not only physical time, but humanity's ability to accept that some journeys are not measured in moments, but in endurance sustained over many years, even many generations. I am telling you about the place where the solar system begins to lose its clear outlines. There are no lines drawn, no sharp boundaries, only a vast transitional region where familiar concepts of planets, orbits, and a central structure gradually become blurred. There, the Kuiper belt spreads out like a cold, misty ring, and Pluto exists as a question mark that lingered for more than a century. Beyond Neptune, space is not as empty as once imagined. It still contains matter, but in a different form. No large planets dominate here. Instead, countless small, icy bodies move slowly through the darkness. The Kuiper belt is home to ancient remnants, fragments of material that never managed to merge into fully formed planets. The Kuiper belt is not a dense band. Like every other structure in the solar system, it is sparse. Objects are separated by enormous distances, yet taken together, they form a broad region extending tens of astronomical units, where the gravity of the central star still exerts influence, but no longer dominates absolutely. Here, motion becomes sluggish. A single orbit can take hundreds of years. Sunlight is so weak that the surfaces of these bodies remain locked in cold. Heat no longer comes primarily from radiation, but from residual energy left over from the time of formation. Pluto lies within this region. For a long time, it was considered the ninth planet, not because it was large, but because it was discovered in an era of limited understanding. As observations improved, Pluto's true nature gradually became clear. It was not alone. It was one of many similar objects, sharing a common dynamical environment. Pluto was not demoted because it was small. It was reclassified because of context. Within the Kuiper belt, Pluto no longer stands out as a solitary planet. It becomes a large member of a population. This change in name does not make Pluto less interesting. On the contrary, it places Pluto in its proper position within a larger story. Pluto is a complex world. Its surface is not static. Nitrogen, methane, and carbon monoxide ice migrate with seasons that last decades. A thin atmosphere appears and disappears as Pluto moves closer to or farther from the central star. This is not a dead block of ice. It is a changing system, even if the changes unfold very slowly. This shows that the Kuiper belt is not a graveyard. It is an active region operating on a different tempo. All processes here are slower, colder, and far more prolonged than in the inner solar system. Time is not measured in generations, but in eras. The Kuiper belt is also the source of many short-period comets. As small gravitational interactions accumulate over time, some objects are nudged onto orbits that carry them inward. When they approach the central star, ice vaporizes, creating the familiar luminous tails seen from Earth. Those brilliant displays originate in this distant, dark region. But the Kuiper belt is not the final edge. It is only where the solar system begins to dissolve out of its tidy image. Farther out, gravity still exists, but it weakens. Orbits become less stable. The control of the center is no longer absolute. At the gravitational edge, the question is no longer where the planets are, but what gravity can still hold. Objects here are not tightly bound. Even a small disturbance from outside can alter their orbits over long periods of time. This boundary is not a wall. It is a transitional zone. There is no moment you can point to and say that the solar system ends here. There is only the gradual weakening of gravitational influence. A process, not a line. This changes how you think about the concept of a system. The solar system is not an object with a fixed shape. It is a region of influence, a volume of space where the gravity of the central star is strong enough to shape motion. As that force weakens, the structure gradually dissolves into its surroundings. Pluto, in this picture, is no longer a special case to be defended or rejected. It is a marker, a demonstration that the solar system does not end with a list of planets, but with a complex transitional region. The Kuiper belt shows that planet formation is not a process completed everywhere. Far from the center, material is not dense enough, time is not favorable enough, and gravitational disturbances are too strong. The result is an unfinished population, where many possibilities exist but are never completed. When you look at this boundary region, you no longer see the solar system as a neat diagram. You see it as a cloud-like structure, dense at the center and thinning outward. An entity with no sharp edge, only a gradual decrease in influence with distance. This also reflects a broader truth. In the universe, very few things have sharp edges. Large structures usually end in fading, not in cuts. The solar system is no exception. The Kuiper Belt and Pluto remind you that naming and classification are human tools, not the essence of nature. Nature does not care about categories. It operates through forces and time. What exists at the boundary does not need to fit old concepts to have meaning. At the gravitational edge of the solar system, you do not find definitive answers. You find transition. And it is within that transition that the picture becomes more honest. No clear center, no simple hierarchy, only a system gradually dissolving into the vastness of space, where influence fades, but never disappears completely. I am telling you about a region that cannot be seen directly, yet defines where the solar system truly ends. Not at the orbit of Pluto, not at the Kuiper Belt, but in a faint structure so vast that all familiar scales lose their meaning. The Oort cloud is not a clearly defined ring. It is the final zone of influence, where the gravity of the central star remains just strong enough to retain the most distant fragments of matter. The Oort cloud is unlike any other part of the solar system. It does not lie in a neat plane. It surrounds the entire system like a gigantic spherical cloud. The objects within it do not move along flat, orderly orbits. They drift slowly along trajectories that can take tens of thousands of years to complete. Distances here exceed intuition. Light takes months, even years, to travel from the inner regions to the far edges of the Oort cloud. At this scale, the sun is no longer a brilliant source of light. It becomes merely a point of brightness, slightly more prominent than background stars, but not strong enough to dominate through visual presence. The objects in the Oort cloud are composed mainly of ice, frozen water, methane, ammonia, volatile compounds preserved from the time the solar system first formed. They are remnants left behind, flung outward during the early chaotic phase, when the giant planets migrated and rearranged their orbits. There is no sharp boundary marking where the Oort cloud begins. The density of matter increases only very gradually as you move outward. At some point, the orbits become so vast and so weakly bound that it becomes difficult to distinguish which objects still belong to the solar system and which are merely interstellar bodies passing through. This very indistinctness is what makes the Oort cloud the true boundary, not because it is a wall, but because it is where the gravitational influence of the central star begins to blend with the influence of the surrounding environment. Here, the solar system is no longer a closed system. It begins to interact with interstellar space. Other stars, passing nearby in the distant past, may have disturbed the Oort cloud. A very small perturbation, accumulated over time, is enough to alter the orbit of an icy object. It then begins a slow fall toward the inner regions, along a long, narrow trajectory. Tens of thousands of years later, it appears as a long-period comet, suddenly crossing the sky. These comets do not come from familiar regions. They are messengers from a distant frontier. Each appearance is the result of a chain of events longer than the entire history of human civilization. They carry ancient material, nearly unchanged since the earliest era. The Oort cloud is therefore not merely the edge of the solar system. It is a repository of formative memory. There, time moves so slowly that chemical processes nearly come to a halt. There is no intense radiation, no frequent collisions, only preservation. However, the Oort cloud is not perfectly static. Gravitational forces from the Milky Way, from nearby stars, and from the solar system's own motion around the galactic center all leave their imprint. Orbits are stretched, gently twisted, altered very slowly but continuously. On timescales of hundreds of millions of years, this structure is not fixed. This reveals an important truth. The solar system does not exist in isolation, even at its farthest boundary. It remains part of a larger environment. The Oort cloud is where two realities meet. The influence of the central star and the influence of interstellar space intersect. If you were to stand on an object within the Oort cloud and look back, the solar system would not appear as a planetary system. It would look like a small zone of influence, where a central point of light retains a handful of nearby objects. Most of the sky would be filled with other stars, distributed almost evenly. There, the concept of a center begins to lose meaning. For this reason, the Oort cloud is not an ending in the conventional sense. It is where the solar system dissolves into its surroundings. There is no sharp moment of separation, only a gradual transition from belonging to no longer belonging. This also changes how you think about boundaries in the universe. Boundaries are not fences. They are blurred regions where influences overlap. The Oort cloud is the clearest example of this within the solar system. Here, distance is no longer the only factor. Time becomes the primary measure. An orbit lasting hundreds of thousands of years, a perturbation accumulating over millions of years. These numbers lie beyond direct experience. Yet, they are the natural units of this boundary region. The Oort cloud also poses an implicit question. If this is the boundary between the solar system and interstellar space, does it truly belong to us? Or is it merely a region where our influence is temporary, before everything continues drifting under larger forces? When you view the solar system from the inside outward, you see a clear progression, from tight order at the center to the sparseness of the Kuiper belt, and finally to the fading indistinctness of the Oort cloud. Each step outward is a step of diminishing gravitational control. The Oort cloud is therefore not a distant appendage. It is the final, complete part of the picture. It shows that the solar system is not a closed structure with a clear boundary, but an open region of influence, gradually merging into interstellar space. At this boundary, there are no markers, no signposts, only icy objects drifting slowly through the darkness, preserving the memory of the earliest times, and marking the place where us gradually becomes the surrounding space. Has been the country stow. And when you imagine the Oort cloud this way, you no longer think of the solar system as a system that ends with a list of planets. You begin to see it as an open structure, whose true boundary is not where matter stops, but where the final influence of the central star fades into the larger universe. I am telling you about how order emerges without any planner. There is no blueprint, no plan, only motion, collisions, and enough time for simple laws to arrange everything into a stable structure. The solar system was not born in quiet. It formed from chaos, and only gradually became stable. At the beginning, there were no planets. There was only a cold cloud of gas and dust, spread through space. That cloud was not motionless. A small disturbance was enough to make it collapse. As it collapsed, it began to rotate faster, not because any engine started, but because motion was conserved. As the radius shrank, the rate of rotation increased. This was the first step toward order. The collapsing cloud flattened into a disk. Most of the material fell toward the center, where pressure and temperature rose until nuclear reactions began. A star was born. The rest did not vanish. It continued to orbit the newly formed center, within a common plane. This plane was not chosen. It was a consequence of the original motion. Within that disk, dust collided with dust. Small grains stuck together to form larger ones. Collisions were not always gentle. Many impacts shattered material instead of merging it. But over time, successful collisions accumulated. Larger bodies began to appear. Gravity started to dominate. Matter was no longer evenly distributed. Here, chaos did not disappear. It was filtered. Stable orbits survived longer. Unstable orbits removed themselves. Objects collided and were absorbed. Others were flung outward or fell into the center. There was no referee. Only probability and consequence. Orbital mechanics is the language of this process. An object orbits a center not because it is tied to it, but because it is continuously falling while always slipping sideways. Falling fast enough not to hit the center, sliding fast enough not to escape. An orbit is a compromise between two opposing tendencies. In the early stages, orbits were not stable. They crossed. They changed. Encounters redistributed energy. Some objects were pushed into more circular paths. Others were thrown outward. Over time, the system favored configurations with fewer collisions. Order was not imposed. It was selected near the center, where temperatures were high. Only rock and metal could survive. Rocky planets formed there, farther out, where it was colder. Ice could persist. Giant planets accumulated mass quickly, capturing gas before winds from the central star blew the rest away. This distribution was not a moral rule. It was a consequence of heat and time. Orbital mechanics also explains why the planets move in nearly the same plane and in the same direction. Not because of perfect symmetry, but because other configurations do not last long. Highly tilted orbits collide more easily. Reversed motions are more easily disturbed. After millions of years, what remains appears orderly. Even today's stability is the result of past chaos. The giant planets once migrated. Orbits shifted. Exchanges of momentum restructured the entire system. Some objects were pushed inward. Others were ejected outward, becoming inhabitants of the outer regions. When migration ended, a new order was locked in. In orbital mechanics, there is no absolute resting point. Only relative stability. Orbits can endure for billions of years, but they are not immutable. Small disturbances accumulate. Resonances emerge. Some fragile configurations persist only because cycles align in subtle ways. Resonance is a clear example of order arising from repetition. When two objects have orbital periods linked by simple ratios, interactions repeat in phase. They can stabilize orbits, or instead pump energy into the system until it restructures. There is no intention, only rhythm. Nearly circular planetary orbits are not the only natural shapes. They are energy-efficient forms within a specific context. Elsewhere, elongated, tilted, or even chaotic orbits can exist. The familiar solar system is familiar because it survived a harsh selection process. When you look at the present order, it is easy to forget its violent past. Yet that past explains why everything lies where it does. There are no planets at arbitrary distances, no random orbits. What did not fit has disappeared. Orbital mechanics does not require metaphysical assumptions to create order. It requires only time. A great deal of time. Tens of millions of years for the disk to stabilize. Hundreds of millions for planets to complete their formation. Billions of years for enduring order to reveal itself. This carries meaning beyond the solar system. It shows that order is not the opposite of chaos. Order is the long-term outcome of chaos when simple laws are allowed to operate long enough. No guiding hand is required. Only space for mistakes to eliminate themselves. When you look at the orbits today, you are seeing a temporary yet stable state. A long moment within a very long history. Every motion has a reason. Every distance has a history. No detail is decorative. The order of the solar system is therefore not a miracle separate from physics. It is physics on a large scale, operating patiently, from dust to planets, from chaos to orbits, from randomness to structure. And when you understand this, you no longer ask why order exists. You begin to see that in a universe governed by laws and given enough time, order is difficult to avoid. Not everywhere, not in a single form, but here, in this solar system, order has emerged, not to impress, but to endure. I am telling you about Earth not as a center, but as an exception, not an exception because it is favored, but because it happens to bring together just enough conditions within a system that does not care about outcomes. The solar system operates according to cold laws. Gravity has no intention, orbits have no goal, and within that indifference, Earth exists as a balance so thin it is difficult to believe. When you look back at the surrounding worlds, the picture becomes clear. Close to the center, heat scorches. Farther out, prolonged cold dominates. A planet that retains too much gas becomes locked in a runaway greenhouse effect. A planet that is too small loses its atmosphere. A planet that is too close is stripped by radiation. A planet that is too far freezes. There are no exceptions born of kindness. Only consequences determined by position, mass, and time. Earth lies between these conditions, not at a single optimal point, but within a very narrow band, far enough that water does not completely evaporate, yet close enough that it does not freeze permanently, massive enough to hold an atmosphere, but not so massive as to trap thick layers of gas that lead to uncontrolled heating. These numbers carry no moral meaning. They simply fit. Fragility begins with the atmosphere itself, a thin layer compared to the size of the planet. yet decisive for everything. It regulates temperature, distributes energy, and shields the surface from radiation and small impacts. If this layer were to thin slightly over long periods, water would gradually disappear. If it thickened slightly with a different composition, heat would be trapped beyond escape. Earth's surface is not static either. It moves. Tectonic plates slide slowly, recycling material, drawing carbon deep inside and releasing it gradually back into the atmosphere. This cycle was not designed to nurture life. It is simply how the planet releases internal energy. But the consequence is a climate stabilized over very long timescales. Time is the factor often overlooked when speaking of exception. Earth does not only require suitable conditions, it requires those conditions to persist long enough. Billions of years without catastrophic interruption, not too many impacts that vaporize global oceans, not the loss of a magnetic field at a critical stage, not orbital disturbances severe enough to shatter stable cycles. Even protective factors are not absolute. The magnetic field weakens over time. The atmosphere constantly tends to escape into space. Oceans can change. Earth is not guaranteed. It is only deferred. Present stability is a temporary state, sustained by a dynamic balance between opposing processes. Life, in this picture, is not the goal of the system. It is a side effect. When conditions allow, chemistry becomes complex. When complexity reaches a threshold, self-replication appears. When self-replication exists, selection begins. No step requires the universe to care. Every step can fail. And in many places it has failed. Nearby worlds demonstrate this clearly. A world that once had water but could not keep it. A world of similar size, locked into heat. A smaller world that cooled more quickly. Earth does not represent the general rule. It represents a rare branch of outcomes. Fragility is also evident in Earth's dependence on external factors. The energy rhythm from the central star remains stable over long periods. The orbit is not excessively eccentric. Axial tilt creates seasons without becoming extreme. These conditions are not fixed forever. They can change slowly, but change nonetheless. The solar system has no self-correcting mechanism designed to protect Earth. If the orbit is disturbed, no force prioritizes restoring it. If the atmosphere is lost, there is no infinite reserve to replenish it. Everything exists because it is currently balanced, not because it must be balanced. In an indifferent system, exceptions are not protected. An exception persists only as long as it remains viable. This does not make Earth less valuable. It makes its value clearer. Value does not arise from favor, but from rarity. When you look at Earth from afar, there is no visible sign that it is special, no unusual glow, no remarkable orbit, just a medium-sized rocky planet circling an ordinary star. Meaning appears only when you stand on its surface and experience the outcome of that balance. Life does not alter the underlying laws. Gravity remains the same. Orbits remain the same. Radiation remains the same. What changes is how a planet responds to them. Earth responds in a way that allows complexity to accumulate. But there is no guarantee that this response will last forever. This places Earth in a unique position of awareness. Not because it is central, but because it is one of the rare places where questions can be asked. In an indifferent system, the existence of an observer is not a given. It is the result of a prolonged chain of fragile balances. When you understand Earth this way, you no longer see it as a permanent foundation. You see it as a state that can change, that can end. And precisely for that reason, it carries real weight. An exception is not a promise. It is an implicit warning. That the conditions allowing life are not common. That stability must be maintained, not assumed. That, in an indifferent system, every complex structure depends on continuous balance. Earth does not need to be mythologized to be important. Its fragility is enough. It exists not because the universe needs it, but because for a very long moment, conditions happened to align, and within that moment, life emerged, evolved, and began to ask about its own circumstances. In a system without compassion, existence itself is already an exception. Earth carries that exception not as a privilege, but as a reality that must be understood clearly, not to inspire fear, but to recognize that everything you know rests on a delicate balance. sustained long enough for you to be here and listening to this story. I am telling you about a very small moment, one that carries the full weight of awareness. Not an explosion, not a dramatic discovery, just a faint point of light, nearly lost against the dark background. A planet seen from so far away that all familiar details dissolve, leaving only a fragile dot suspended within infinite darkness. At that distance, Earth is no longer oceans, no longer continents, no longer clouds or city lights. It no longer bears the shape of a world. It is just a single pixel, hanging in space, accidentally captured within the field of view of an instrument turned back toward its point of origin. A moment not designed to glorify, an image not created to move emotions, and precisely because of that, it carries a meaning deeper than any symbol. The pale blue dot is not an abstract concept. It is data, an honest record of Earth's position within its own system and, beyond that, within the entire structure of the universe. At that distance, Earth does not occupy a central place. It does not stand out. It is not highlighted. If it were not pointed out, it would be easy to miss. This creates a quiet shock in the way you see yourself. Every grand narrative of absolute importance dissolves when the planet containing all of human history is reduced to a single dot. No borders, no nations, no cities, no victories or defeats. Everything that has ever happened exists only within a point of light, too small to assert itself. And yet, here a paradox appears. That dot is not only the object being observed, it is the place where observation occurs. Within the entire frame, there is only one point that contains beings capable of understanding what they are seeing. For the first time, the universe does not merely exist, it is perceived. Nothing in the laws of physics requires this to happen. No equation guarantees that matter will organize into life, then further organize into consciousness, then develop far enough to question its own origins. And yet it happened. Not everywhere, not inevitably. Only in one place with sufficient conditions, over a long enough span of time. The pale blue dot marks the moment when smallness no longer means insignificance. When you realize how small Earth is, you also realize that size is not the only measure of meaning. Meaning appears where awareness exists, not where mass or energy is greatest. I tell you this neutrally, without romanticization, without consolation, just as a clear fact. In a universe so vast that light needs billions of years to cross it, a small rocky planet developed enough complexity to look back at itself from the outside. This is not a victory. It is a rare state. The pale blue dot moment did not change Earth's orbit. It did not slow the expansion of the universe. It did not affect physical processes unfolding anywhere else. The only thing that changed was the awareness of the beings living on that dot. For the first time, their position was no longer defined by maps or tradition, but by real distance. When you look at that image, familiar conflicts shrink, not because they do not matter, but because the context has changed. Every concern, every ambition, every fear unfolds on the same fragile platform. There is no backup planet, no alternative center. The pale blue dot is also not a moral lesson in humility. The universe does not demand humility. It offers no lesson. It only reveals scale. What you choose to draw from that scale is the responsibility of consciousness, not of space. In this moment, you may understand that consciousness is not opposed to the universe. It is an expression of the universe at a very high level of organization. The atoms in your body were forged in ancient stars. The forces that govern planetary orbits also govern the activity of the brain. There is no absolute boundary between observer and observed. When a being on Earth sees the pale blue dot and understands its meaning, the universe is not merely seen. It reflects itself, not through a physical mirror, but through awareness. This is not self-awareness with intention. There is no purpose. And yet it is self-awareness in the purest sense. This does not make humanity central. On the contrary, it places humanity in its proper position, a small part within a vast system, yet a part capable of understanding the larger picture to some extent. Not completely, not perfectly, but enough to recognize that it exists within something far greater. The pale blue dot does not ask you to believe anything. It does not need to be interpreted spiritually or within any specific philosophical framework. It simply exists as visual evidence that every story of greatness must be placed within the context of real space and time. I tell you this not to conclude, but to pause, as the journey through the solar system closes, not with a physical boundary, but with a moment of awareness. You do not stand at the center. You are not erased. You exist on a small dot, small enough to be forgotten, yet complex enough to look back at itself. In an indifferent universe, this changes none of the laws, but it changes how you understand your own existence. Not as something inevitable, but as a rare possibility that happened. The pale blue dot does not say that you are more important than the universe. It only shows that the universe, through you, had a moment to look back at itself. And that moment, however small, remains part of a larger story that needs no one to tell it on its behalf.